Hello everyone, once again I'm Erisa Wante. I'm back to teach you trigonometry. In lesson 2 we discussed the quadrants and the behavior of ratios in the different quadrants. We discovered that if you divided the plain paper with the coordinate axes, then you will get 4 parts, and each of these parts is called a quadrant. And like positive angles, these quadrants are numbered in an anti-clockwise sense. So this is the first quadrant. This is the second quadrant. This is the third quadrant. And then you have the fourth quadrant. So we discovered that the behavior of ratios in the quadrants, we say that for the first quadrant, the angle it consists of angles between 0 degrees and 90 degrees, and those angles were called acute angles. Second quadrant is obtuse angles between 90 and 180 degrees. When you got the third quadrant and the fourth quadrant, angles in the third and the fourth quadrant are generally called reflex angles. So we discovered this last time that for in the first quadrant, all ratios are positive. In the second quadrant, it is sine that was positive. Then this is tangent and cosine. So all this was discussed last time. Now, we ended the discussion with something very important, the inclination properties. Inclination property of angles. Okay, we say that angles that are equally inclined to the positive or negative x-axis have trigonometric ratios of the same magnitude, and the sign of the ratio is determined by the quadrant in which the angle lies. So that point is very important. I want to discuss a few examples about that today. I will begin by writing it down for you to remind you what we discussed last time. Then I start working out problems. So this is the point that I'm talking about. One important property to note is that angles for which the vector OS is equally inclined to the positive or negative x-axis have trigonometric ratios of the same magnitude. Their sign, okay, the sign we mean positive or negative, is determined by the quadrant in which the angle lies. We want to discuss this example, okay? We are required to express cotangent of 150 degrees in terms of trigonometric ratios of an acute angle. So this is what we do, okay? 150 degrees is a positive angle. So you start from the positive side of the x-axis and draw it in an anti-clockwise direction. That's 150 degrees. Okay. Now, this is the vector or the line you draw in a quadrant. I'm calling it OS. Some books use R, they call it OR. Okay. So this is my vector OS. Now, and the gap or the angle left to reach the x-axis is the angle of interest, and this case is going to be 30 degrees. So the cotangent of 150 degrees, you know cotangent is 1 over tan, okay, is going to be compared with the tan of 150 degrees. But we know this is second quadrant where tangent is negative. So write this as 1 out of tan 30 degrees. Yes, it is going to be tan of 150 and tan of 30 have the same values, but one is a negative. So tan of 150 is negative. So you put a negative on the tangent of 30 to balance it with that of 150. Okay, so we have expressed the cotangent of 150 degrees. Okay, it is now equal to 1. So negative 1 out of tan 30 degrees. I have shifted the negative in the numerator, but 1 over tan we take it back in terms of cotangent. So this is going to be the cotangent, okay, a negative cotangent of 30 degrees. And we have expressed this in terms of a ratio of an acute angle, okay. The cotangent of 150 degrees is the same as the cotangent of 30 degrees, but it's a negative, okay. So Let me discuss a few more examples. So these are examples. I will discuss a few, then the rest will be for you. Expressed in terms of trigonometric ratios of acute angles. Okay, so we want to express in terms of trigonometric ratios of acute angles. The first one is sine of minus 50 degrees. The second will be the sec of minus 172 degrees. The third is going to be cos of 293 degrees. The fourth will be the sine of 325 degrees. Then the fifth will be, I'm just picking a few here. I have many. You can find so many in Backhouse. That's one of the books I'm using. Okay, Backhouse 1 on page 325. You'll find some of this information. Okay, did 325? Let me check the page. The page is 329, 28, 29. Okay, you'll find this information and you can do a self-service, do as many as you want. The cosine of minus 130 degrees. Okay, the cosecant of minus 53 degrees. Then we have tan minus 140 degrees. Okay, as number 7. Then number 8, we have, what else can I give you here? We have cot 156, that we have done. We can look at the cos of minus 20 degrees. Okay, so we are required to express these ratios in terms of ratios of acute angles. Okay, so I will pick a few, then I leave you to do, maybe let me do 3, then the rest will be yours. Okay, so sine of minus 50 degrees. So sine of minus 50 degrees, what you do is to locate where the angle minus 50 is. So we said we start from the positive side of the x-axis. Okay, this is x-axis, and move in a clockwise direction. If the angle is negative, we are going to move in a clockwise direction. Okay, this is the angle which is minus 150 degrees, but because I have used the arrow to show me where the angle is pointing, I don't need to put negative here. I will put just 50 degrees. Okay, and the requirement is sine of minus okay, sine of minus 50 degrees. Okay, we look at the inclination, that is the angle between the x-axis and the line OS. So the angle is already 50. Okay, this is going to be compared with the sine of 50 degrees. Okay, but this angle negative 50, in which quadrant is it? It is in this quadrant here, which is the fourth quadrant. And in the fourth quadrant, only cosine is negative, so we put a minus here. Okay, so the sine of minus 50 degrees, okay, is going to be the negative sine of a positive 50 degrees. Okay, and we are done. So next is sec. Let me look at sec of 172 degrees. The secant of minus 172 degrees. Okay, we begin by locating the angle 172. Okay, where is 172? From what we know so far, this angle is a negative angle, so we move in a clockwise direction and measure 172. 172, of course, don't reach 180. Okay, this is 172 degrees. If I put an arrow here, it's already showing that I have measured it in an anti-clockwise direction. So I don't need to include a negative. Okay, if you want, you can include. Okay, there's no problem. But now the point of interest is the gap, this angle here, the angle between OS and the x-axis. Okay, is the angle of interest. This is the acute angle they're talking about. So 170 divided with 80 degrees to make 180, and therefore the sec of minus 172 degrees. First of all, take this in terms of, a reciprocal. Sec is 1 over cosine. This is the cosine of minus 172. Cosine of minus 172. Minus 172 degrees. Okay, so we are discovering that this angle is lying in the third quadrant. It is in this quadrant here. Okay, the third. And in the third quadrant, so now this is the point when we are changing from the angle given to the acute angle. We are going to compare this. We are going to compare cosine of negative 172 degrees with the cosine of 80 degrees, because that is the inclination. But because it is in a quadrant where cosine is negative, we put a negative. Okay, so in the end, we have something interesting. We have the secant of minus 172 degrees has changed to 1 over negative cosine of 80 degrees. But 1 over cosine is a secant, so this is minus secant of 8 degrees, and we are done. Okay, we are done. That is it. There's nothing so much here. But it is important because we shall use this so much when we are solving trigonometric equations. For example, you are given to solve sine of theta. Let me just begin with theta. Sine of theta equals negative a half. Okay, why are we saying that the inclination property is so important in solving an equation? We know that the sine is negative. The first thing we have to do is to analyze the ratio given to us. This ratio is a negative. Okay, so it means that the angles in quadrants where sine is negative, so we have an angle here and an angle here. Okay, we are going to draw a line up to some point here. We have one angle, and then the other angle is going to be in this other quadrant from the positive side. Of course, the question will specify if they want you to get a positive angle or a negative angle. So I can say that for 0 degrees, let's say equal to theta, let's say equal to 360 degrees. We are dealing with a positive angle. Okay, so sine, we are looking for an angle here. Okay, theta, between the x-axis and this line. Okay, whose sine, we know that we're looking for sine theta is equal to a half. The negative is like it is a direction, or it is something telling you that you go to a quadrant where sine is negative. So when you are computing here, if you want to get it, when you are computing, don't indicate a negative. Okay, so because we're looking for the inclination, this other angle here, you are looking for this angle, this acute angle. Okay, you know all acute angles have positive ratios, so we are looking for this angle, and we are saying its sine is a positive a half, not negative a half as given the equation. Negative just took us the quadrant of interest. So theta will be the sine inverse of positive a half, which is 30 degrees. So this angle is 30 degrees. 30 degrees, and this angle also will be 30 degrees. Okay, so what we are left is reading off the angle from here. If that is 30 degrees, then this angle is going to be a negative, it is a positive 330 degrees. Okay, and this is going to be 210 degrees. Okay, therefore, if we are solving sine theta equals negative a half, and want to write to get the values of theta, which will be the sine inverse now of negative a half, then we have two angles, 210 degrees and 330 degrees. Okay, so this is why I'm talking about the inclination properties of angles. It is really so important that you understand what I'm talking about. Okay. Next, we are given sine of, let me do one positive, sine of 250 degrees in terms of an acute angle, okay? So what you have to do first is to draw the angle 250, start from the positive, move. If you go here, it will be 270, so you don't reach the negative y-axis, and therefore it means that we are stopping somewhere on the way. Somewhere. Oh, let me redraw this. I wanted to rub and then do it, but I end up making a mistake. So let me do it again. 250 is this angle, okay? 250 degrees. Please, this is important. We look for the angle between the x-axis and the vector, okay? The vector OS. This is OS, but I will stop calling it OS. So what we do here is to look for, first of all, this angle. If we are to express, I know that if I move from here up to this point, it is 180. So what I need is to get 250 minus 180, and I have that other angle I'm looking for, okay? 0, 15 minus 7, so that's 70 degrees. So this angle is 70 degrees, and therefore the sine of 250 degrees will be compared with the sine of 70 degrees. That's the acute angle they're talking about. Now the next question is the quadrant, okay? 250 degrees is in the third quadrant, and we know in the third quadrant it is only tangent that is positive, so put a negative here, and you have expressed the angle in terms of the ratios of an acute angle. You have expressed the ratio of sine 250 in terms of a ratio of an acute angle. So it is not a big deal. It is something really very simple that you can always do. Okay, one more example for you. The cosine of minus 130 degrees. Okay, let's see. 130 degrees, negative 130 degrees. You start from the positive x-axis, move in the clockwise direction, and make 130 degrees. Okay, 130 degrees negative. So this is the angle I'm interested in. Okay, let me put an arrow to show how I measured in an anti-clockwise sense. Okay, so if this is 130 degrees, you know that should be 180 if we complete and reach the negative side of the x-axis. So we are not reaching the negative side of the x-axis, but we are reaching this line OS to make negative 130 degrees. So this is going to be 50 degrees. Don't again call it negative 50, no. Okay, the negative is to show you direction of measurement. Okay, so 50 degrees, and the cosine of 130 degrees is going to be compared with the cosine of 50 degrees. Okay, but now the question is, in which quadrant? That's again third quadrant, like the previous question. And in the third quadrant, only tangent is positive, so this carries a negative. So we are done. This is something very simple. You try it out. Try so many examples. I told you, go to Backhouse 1 on page 328. There is a lot of examples that you can do about this. So next, let's talk about graphs of sine theta, cosine theta, and tangent theta. Okay, we begin with the graph. The graph of y is equal to sine of theta. Now, if we are to plot the graph of y equals to sine theta, you have to consider a vector OS of length 1, the easiest way, okay, to come up with this graph of y is equal to sine theta is to consider the vector OS to be 1 unit, okay, either 1 kilometer, 1 whatever, as long as it is 1 unit. We have seen how angles behave in the different quadrants. Okay, so this is the angle theta we are talking about. We will move in the positive direction, so we have positive angles, and also in the negative direction, so we have negative angles. But what we need most is, as this moves, as this vector OS moves, it will plot a circle. I cannot be perfect because I'm using a free hand to explain this to you. But if I give you an animation, unfortunately I don't have the copyright for this animation, but you can go to Wikipedia or you go to any YouTube channel and see those with animations. I don't have any kind of animation to give you, okay? But I want a situation whereby this is moving. So I'll use about 4 colors, okay, to explain what I'm talking about. I'll use, this is, let me call this position 1, it is B1, or let me just say S1 since I'm using S. This is S1, the first position, okay? Then it moves to another position here, which I will call S2 in a different color. So I messed up my everything. Okay, let me do this and do this, then this. Okay, so in a blue color, let me have this as the next angle. Okay, theta here. This is still theta. Okay, then it goes somewhere here. That's another angle, theta still. Maybe I use red for this. This is another angle, much bigger than the first one. Okay, positive angle. Now, we know, let's now come to the first one. This is a vector OS of length 1 unit, 1. Okay, let's call this point N. So we know that it is, if it is 1, then the coordinate of this point will be 1 and 0. Then here, somewhere here it will be 0 and 1. Then negative 1 and 0. Then you have 0 and negative 1. Okay, so as that vector moves in position S1, this is S2, this is S3, okay? We can have more here when it goes to the second quadrant, and you have this other angle, okay? So you have this and this. In each case, you can see that as we move from the positive side of the x-axis and move anti-clockwise, the y value keeps increasing, S1n keeps increasing, okay? So we have sine theta, okay, is Sn opposite out of 1, okay? So this is just Sn. But Sn is the y value here, the y value, okay? So what do you see? As the angle moves, as the angle increases from 0 to 90, okay, we have theta and then the y value. As we move from 0, because the y value here, if the angle is 0, you are just lying across just lying along the x-axis, and the y value is 0. So if this is 0, then this is going to be 0. Okay? If the angle increases to what we can read off from what I've drawn, values of angle 0, 90, 270, but there are so many angles between 0 and 90. Okay? So if you got 90 degrees, then the y value becomes 1. Okay, if you go to this other position here, this is position, maybe this is, let me call this A, this is B, this is C, and this is D. So this is at A. At B, the angle is 90. Then at C, the angle becomes 180. Okay, but what's the y value there? Y value reduces to 0. Okay, then as you move down here to 270, the y value becomes negative 1. And then 360, okay, y value is 0. So A, B, C, okay, D, and then back to A. Okay, so we have completed the complete revolution, but you can do it somewhere and try to imagine what I'm talking about here. Okay, so what do we do? How do we come up with the sine curve? Is that from this, the y value cannot be more than 1 and cannot be less than -1. So the sine curve, you plot angles, okay? And on the x-axis, put theta. On the y-axis, put the values, okay? Y is equal to sine theta. The first thing you have to know, oscillate between +1 and -1, okay? From here, 0, then we have 90, we have 180, we have 270, okay? And then we have 360. Let me try to extend this somewhere here. So we can see we have 360. I need to rescale. My scaling is not really good. Much as I'm trying to estimate, I don't have kind of rulers. I can do better than what I'm doing, I believe. So this is 90, this is 180, this is 270, this is 360, this is a -90, this is a -180, -270, -360. So sine of 90 is a +1 and this is a -1, okay? So this is for 90. There are many angles between 0 and 90 degrees, but we cannot read off from the diagram I've just tried to draw for you. Then when you go to 180, it comes to 0, okay? 270, it goes to -1. 360, it goes back to 0. So sine has this kind of behavior, okay? It moves like this, then keeps going. If you are to measure negative direction, then you have here, then back to 0, then a +1 here, okay, and then back to 0 at this point. So you'll have something like, okay, and this is y equals to sine theta. I believe you try to sketch some of these curves at ordinary level, but I'm trying to remind you, one important thing you have to note here is that sine, okay, sine theta is between -1 and +1. Sine of theta, okay, is less or equal to 1. That means that from -1 less or equal to theta less or equal to +1, okay? So it is actually sine of theta is less than 1, okay? The magnitude is less or equal to 1 of sine theta. So it is between -1 and a +1. Cosine will have the same graph, but it is just shifted to the right, okay, by 90 degrees. So if I have here 90, 180, 270, 360 for cosine, it is exactly the same as that of sine. It's only that the starting points are different, okay, -90, -180, -270, okay, -360. 90, 180, 270, 360. So cosine, and the cosine is the x value, okay? When the angle is 0, cosine is already 1 somewhere here, okay? Sine and cosine have one uniting property. They are all maximum 1 and minimum -1. So this is 1. So cosine of 0 is already 1. Cosine of 90 is 0. Cosine of 180, -1. Cosine of 270, 0. Cosine of 360, +1. Okay? And the same happens on this side. Okay? It keeps going the same way. So you have something. It is turning here. It's turning down here. It's turning down here. It is turning up here. So you connect those points. This, and something like so. That's how you sketch some of these curves. Y equals to cosine theta. So I will not really dwell so much on the graphs. I want you to come up with these graphs by, on your own. You can do it, I'm very sure. Okay, you try to sketch sine. You can try to sketch sine 2 theta. Okay, it is compared to that of sine theta. Anyway, if you have problems, we shall be discussing this, but the point I want to emphasize here is that sine and cosine have both the maximum value 1 and minimum value -1. All right, today's lesson has been short, but I wanted to talk about the graphs briefly, sine, cosine, tangent. I didn't talk about it, but still you can find an animation about it on Wikipedia and get to know how tangent behaves. So we are going now to start looking at serious work, solving equations, Pythagoras theorem, identities. So it's really going to be very, very interesting. Today I did my filming from my office here, but it's just a simple office. Anyway, yeah, I wish you the best. Let's meet in the next video.